Lecture, we're going to talk about the concept of kernel modules, what they are, why they're there, and basically how to manage them. This is a basic lecture from the perspective of a Unix end user, and the whole idea here is just to start getting an idea about how we can probe our system for some information and start to understand what's going on at a little bit of a deeper level. So let's take a look at some slides and talk a little bit about what kernel modules are. Then we'll jump over to the command line and we will take a look at how we can interact with the system to find out what modules are installed and how to unload and load modules. First thing you need to know is that kernel modules serve the basic need of the system to talk to hardware. And your kernel is the low-level aspect of your operating system that basically sits between the hardware and the user and applications. And the kernel's job is to know how to talk to the CPU. The kernel's job is to know how to talk to all of the attached devices like network cards and hard drives, and basically just deals with translating any type of application directive that needs to then go ahead and talk to the hardware. And the kernel is really great. Like, it sits between you and your computer, and it just knows how to talk to these devices. For the kernel to know how to talk to some piece of hardware, it needs to have a module that can tell it how to do that. And those modules usually can exist inside of the kernel. In other words, they can be compiled in, and the kernel can have that knowledge kind of built into its brain. Or those modules can be actually stored external to the kernel and loaded when needed. There's some more details related to that process, but for now we can kind of use this higher level abstraction of understanding that kernel modules give us the ability to add functionality to our operating system's lowest level so that we can talk to additional pieces of hardware. What we're going to notice is that on the system, the kernel modules that can be plugged into the kernel while it's running or plugged into the kernel at boot time will be stored in lib modules. And this directory contains all of the compiled kernel modules that you have for your system. So again, these are very similar in Windows to drivers. You get a new printer, you plug it into your Windows machine, and before Windows can actually print something, you usually need to go out and download a driver, either through Windows Update or from the manufacturer's website. And it's really no different with kernel modules. You have a new piece of hardware, the kernel needs to know how to interact with that hardware, and you have a driver to install. And again, in the case of the kernel modules that we're going to look at in lib modules, we're talking here about modular kernel modules. I know that sounds a little weird, modular modules, but these are the basically the bits of code that can be loaded and unloaded from the kernel at runtime. For some aspects of driver support for Linux or hardware support, it makes sense to have that knowledge embedded in the kernel, and so it can never be removed. And again, this is like a higher level system concept, but just know that the pieces that we're talking about are those modules today that can be loaded and unloaded. So let's talk a little bit about how we do this. We can see all the currently loaded modules that the kernel has by using the lsmod command. We have the ability to install a new specific module with insmod. Sometimes kernel modules will require other kernel modules to do everything they need to do. So we can use the mod probe command to load a module and then any other dependency kernel modules that it might need. And we can rm mod a module from the kernel. So why would you want to take a kernel module out at runtime, or why would you want to put a new one in? Maybe you're having some system instability. The ability to rm mod a kernel module and take it out of the kernel while it's running could be a way to figure out if a connected piece of hardware and its associated kernel driver is causing system instability. Sometimes you might also have not a need. Maybe you plug a tape drive or something into a machine once a month to get some type of backup or verify backups, and you just don't feel that that driver needs to be loaded full time in the kernel. You have the ability to just use the mod probe command to load that driver into the kernel when you need to use that specific piece of hardware. So again, it just gives you all types of flexibility. Again, rm mod could also be used like in Windows when you right click on a specific device to disable it. So you want to disable a piece of hardware that you don't think is working efficiently. You can just remove the kernel module and get a similar effect in Linux. So let's jump over to the command line and see how these work and how they look on my system. For this part of the exercise, I'm going to be logged in as the root user. It just makes things a little bit easier, and I will not have to constantly keep typing sudo. In the cases when you interact with the kernel and try to load and unload kernel modules, it's probably best to use sudo just to make sure that you're only doing that one thing as root and not going to cause any trouble. It's always bad to constantly work as root, in my opinion. So anyway, let's take a look at some of the drivers currently loaded into the kernel. So if I type lsmod, you'll see a whole number of items that are listed here. And if we scroll down, it kind of lists the name of each one of these drivers. And then you'll notice over on the right-hand side, it gives you information on any of the drivers that have dependencies. So if, for any of these drivers, if they rely on another driver, you'll see that here. And from here, from this standpoint, I can go ahead and I can start to remove things should I find that there's anything troublesome. So LP is the line printer driver, so let's go ahead and get rid of that. So I can type rmmod to get rid of it, and you'll notice that I get no feedback, so it must have happened. And if I type lsmod at this point and look down towards the end of the list of kernel modules, you'll notice that that module is gone. So this idea that we can see what current modules are loaded into the kernel, we have the ability to remove modules that could be troublesome. And then we also have the ability to load them back in. There is an insmod command, but I prefer to use modprobe because it's going to handle any type of dependencies. So let's load it back in. And now if we do lsmod, you'll notice that that kernel module will be right at the top of the list because we loaded it back in. So we have the ability to load, unload kernel modules, and that's pretty cool. The modules themselves are stored in /lib/modules, and if we look in that directory, you'll notice that there are different folders based on different versions of the kernel. I will go into this one, and if we take a look, you will notice that there are a bunch of other things going on in here, lots of information regarding the modules that are currently built for the kernel, and I'm going to go into the kernel directory. And you'll notice that the modules that are available for the system are organized into specific folders based on kind of what they do. I notice some of they're specifically drivers, and I'm using the term kind of generically. But notice you can tell that some things are related to network operation, some are related to sound. So let's go take a look at stuff in the net folder. So in here, what you'll see is information related to all different types of networking services, like Bluetooth services, AppleTalk, and you get an idea of all of the available kernel modules that come with the default Ubuntu. This is the version 12 long-term support version of Ubuntu. I mean, these are pre-built with the kernel that comes with this distribution. Obviously, when you rebuild your own kernel, you have the ability to control what modules you compile and actually which functionality you compile into the kernel itself or leave separately as a module. So again, this gives you the ability to kind of start to understand that, for the kernel to talk to some external hardware, it needs to have a driver, which will be represented by a kernel module, and that kernel module needs to exist on the system, and it needs to be loaded up into the kernel so that you can use that piece of hardware. And if we were to explore any of these directories any further, you'd find some more information about the items that are in there. And you'll notice that